Good morning, everyone. And today I'm going to derive the solution of a two-dimensional Laplace equation. And this is very important for physics honor students and mathematics honor students, for BSc students, and also it is very important for BTech also. Okay. So let us see what is the Laplace equation in two dimensions. Laplace equation in two dimensions. And the Laplace equation in two dimensions is del square u by del x square plus del square u by del y square is equal to 0. Or this can be written as uxx plus uyy is equal to 0. We can write like this also. Or we may write like this also, del square u is equal to 0. That is grad square u is equal to 0. Where del square means del square by del x square plus del square by del y square. Okay, that means I am writing here del square means it is equivalent to del square by del x square plus del square by del y square in two dimensions. And in three dimensions it will be equal to plus del square by del x square plus del square by del y square plus del square by del z square. Okay. Or you may write delta of u is equal to 0. Okay. So we have to find out the solution of this equation. Okay. So let us find out the solution by variable separable method. Okay. So solution of Laplace equation. Let u of xy is equal to f of x into g of y be the solution of Laplace equation. Okay. So automatically it will satisfy the Laplace equation. Now our Laplace equation is, see here, uxx plus uyy is equal to 0. So this becomes uxx means you have to differentiate with respect to x. Y is constant. So partial derivative of u with respect to x twice. That means second order partial derivative of u with respect to x. So here f is a function of x and g is a function of y, and we are following the variable separable method. Okay. So that means we should differentiate f only and keeping g constant. So I can write f double dash into g because g is kept constant and derivative with respect to x means twice. That means f double dash. And u with respect to y twice. That means we should differentiate g twice. So keeping f constant. So g double dash is equal to 0. Clear? Now let us separate the variables. F double dash g is equal to minus f g double dash. So f is a function of x and g is a function of y. So I am writing f double dash by f. That means I am dividing f and g. F into g on both the sides is equal to minus g double dash by g. Okay, and this is possible. These two will be equal. That means left hand side is a function of x and the right hand side is a function of y. And this is possible only if each is a constant. If the left hand side and right hand side will be equal to a constant quantity, then only it will be equal. So it is equal to constant. So let it be k. Okay. So now case 1. If k is equal to lambda square. I am taking k is equal to lambda square. That constant is equal to lambda square. So now f double dash by f is equal to lambda square. So it implies I am cross multiplying f double dash is equal to lambda square f. Clear? So take it to the left hand side. F double dash minus lambda square f is equal to 0. Now auxiliary equation is, so how to find out the auxiliary equation? It is known to you in ordinary differential equation. Okay. So in place of f, I am writing 1, and in place of f double dash I am writing m square. M square minus lambda square is equal to 0. So implies m square is equal to lambda square. I am taking lambda square to right hand side. So m is equal to plus minus lambda. So this is the case of real and distinct roots. So the solution is, here the variable is f. Okay. So solution is, in this case, f of x is equal to a into e to the power lambda x plus b into e to the power minus lambda x. So this is the solution. In this case, when the constant is equal to lambda square. Okay, and this is the solution for f of x. Okay, now for g of x here, minus g double dash by g is equal to constant. Okay, and the constant I have taken lambda square. So see here. Now minus g double dash by g is equal to lambda square. So multiplying minus on both the sides, we get g double dash by g is equal to minus lambda square. So it implies by cross multiplication g double dash equal minus lambda square g. Okay. So take to one side g double dash plus lambda square g is equal to 0. This is second order linear differential equation. So again right hand side is 0. So auxiliary equation is m square plus lambda square equal to 0. So it implies m square is equal to minus lambda square. So m is equal to plus minus lambda into I, imaginary part, because negative sign root over of minus 1 is I. Okay, so this is the case of complex conjugates. So now therefore g of y, g is a function of y, that is why I am writing g of y. But f is a function of x, in that case I have written f of x. Okay, so c into cos lambda y plus d into sin lambda y. So this is the value of g of y. Now the solution I have written, see here, the solution I have taken u of xy is equal to f of x into g of y. See here, I have first taken u of xy is equal to f of x into g of y with the solution of the Laplace equation. F of x I have got, g of y I have got. So the solution in this case, in the first case, what will be the solution? See here. Now in this case, the solution is u of xy is equal to f of x into g of y is equal to f of x. I have written a into e to the power lambda x plus b into e to the power minus lambda x into g of y, c into cos lambda y plus d into sin lambda y. So this is the solution for the first case when the constant is equal to lambda square. Okay, so let us consider the second case, the case 2, when k is equal to minus lambda square. So f double dash by f is equal to minus lambda square. So it implies by cross multiplication is equal to minus lambda square f. So take it to one side. F double dash plus lambda square f is equal to 0. Now the auxiliary equation will be m square plus lambda square is equal to 0. So m square is equal to minus lambda square. That means m will be equal to plus minus lambda I. But here f is a function of x. So that is why the value of f of x will be a into cos lambda x, because f is a function of x. That is why I am writing x, and b into sin lambda x. Again, for g minus g double dash by g is equal to minus lambda square. So cancelling minus from both the sides and cross multiplying, g double dash is equal to lambda square g. Clear? Now taking over to one side, g double dash minus lambda square g is equal to 0. So auxiliary equation is m square minus lambda square is equal to 0. And the value of m is plus minus lambda. Therefore, g of y, g is a function of y, that is why I am writing g of y. G of y is equal to c into e to the power lambda y plus d into e to the power minus lambda y. Because g is a function of y, that is why I am writing y. So therefore, solution is u of xy is equal to f of x into g of y. And here f of x is a into cos lambda x plus b into sin lambda x, and g of y, it is c into e to the power lambda y plus b into e to the power minus lambda y. So this is the solution in the second case when the constant is equal to minus lambda square. So let us see the third case. Case 3. When a is equal to 0, because 0 is also a constant. So f double dash by f is equal to 0. That means f double dash is equal to 0. P by Q is equal to 0 means P is 0. Don't say after cross multiplying we are getting f double dash is equal to 0. P by Q is equal to 0 means P is 0. Clear? So integrating, we get f double dash is equal to simply a constant of integration, and we are integrating with respect to x because f is a function of x. Again integrating with respect to x, f is equal to a into x plus another constant b. So that is f of x. Similarly, minus g double dash by g is equal to 0. So it implies g double dash is equal to 0. So it implies g dash is equal to, that means integrating both the sides with respect to y, because g is a function of y. So g dash is equal to c, where c is a constant of integration. And again integrating with respect to y, g of y is equal to c into y plus d. D is another constant. Therefore, solution is u of xy is equal to f of x into g of y. Clear? So here f of x is equal to, here we have got ax plus b and g of y cy plus d. So this is your solution in the third case. So there will be three cases. If the constant is equal to lambda square, so we have got the first case, and if the constant is equal to minus lambda square, we have got the second case, and if the constant is equal to 0, then we have got the third case. So there will be three cases for the Laplace equation. Okay. So according to your problem, according to given data, you should choose which one is suitable for you. That means whether case 1 is suitable, or case 2 is suitable, or case 3 is suitable. Okay. So in the exam, it will be given that derive the solution for the Laplace equation in 2 dimensions. So you should do 3 cases. Case 1, case 2, case 3. Okay. So this is all about the solution of the Laplace equation in 2 dimensions. In my next video, I'll tell you how to solve the wave equation problems. Okay. That means I will do the problems of wave equation with different conditions. Okay. And it will be very interesting. So very soon I am going to give that video. Okay. So till then, bye bye.